last new material in this unit is dividing polynomials by a binomial. So the thing you have to understand is division, or the fraction bar, takes priority in terms of, see all this adding and subtracting? You can't divide adding and subtracting. You can only divide multiplication. So what we have to do is turn the numerator into multiplication by factoring it. And we have to treat the denominator, the x minus 1, as one whole chunk, one whole term. That's why I put parentheses here. So hopefully there's a x minus 1 factor in the numerator. Well, if you remember, with our mixed factoring, if there's 3 terms and there's a 1x squared, we can do the shortcut trinomial, and we just do a times c, so that's 1 times -8, that's -8, and the b is 7. So we need a negative times a positive, but we need more positive, so it's +8 and -1, which actually works out because I can already tell, well, that means the numerator is going to factor, because we can use the shortcut, we split up the x squared into x times x, and then we have the -1 and the +8, and then the denominator is x minus 1. Well, because we treat these binomials, the x minus 1, as one whole chunk, and one of the factors is x minus 1, we can divide these out. Just like 5 divided by 5 is 1, anything divided by itself is 1. So the same thing happens. So the final answer is x plus 8, and you don't even need parentheses. So basically you're going to do that for all of these. So like, for example, on number 4, the numerator, you're going to do GCF, because this is not a difference of squares like this one, which we'll do in a second. So the GCF of the numerator, I can tell, is 2x. So when you divide out a 2x out of each one of those, you get 2x times x plus, 8. I was going to write 16, but I have to divide that by 2x, or 16x by 2x. All over the denominator is x plus 8, and then we know that these divide out because we have to treat the denominator as one whole piece, or one whole factor. So the final answer is just 2x. Okay. So like in number 3, the y squared minus 25. So there's 2 terms, there's no GCF, but that's a difference of squares, so I can automatically factor and split up the y squared into y times y, and we need our plus and our minus so that the middle term factors out, and then the root of 25 is 5. And then since the denominator is y plus 5, we can divide out those factors. Again, remember, you always want to put the denominator or the binomial in parentheses. So the final answer is y minus 5. Okay. So if you look at number 5, we have a trinomial in the numerator. We know the denominator is going to be one whole factor, so I'm kind of hoping that 2x minus 3 is a factor of the numerator, so that it reduces. Basically, when you divide out common factors, you're reducing the overall fraction. Okay, so that's basically what we're doing. Algebra 2, you're going to be doing a lot of this. So since it's a trinomial, there's no greatest common factor, so we have to do the full x method because a is not 1. So when we do a times c, 2 times -12 is -24. Your b is 5. We need a negative times a positive, but we need more positives. So it's +8 and -3. Let's just do some side work. So remember, for the full method, we have to replace these two for the old middle term, and we get 2x squared minus 3x plus 8x minus 12. So the GCF in the first term is x, our first pair, and then the second pair, it's 4. So we get x times 2x minus 3 plus 4 times 2x minus 3. So it's x plus 4 times 2x minus 3. is what the numerator factors into. So the numerator looks like x plus 4 times 2x minus 3. And then since the denominator is 2x minus 3, we know that those two factors divide out, and the final answer is x plus 4. Okay. So go ahead and do, let's see, actually, let me see if there's another type. Oh, yes. Okay, so on the back side, so the fraction bar we know is division. These are the same. You could rewrite this, like for example, I can see that c squared plus 8c minus 33, we can do the trinomial x method shortcut. So the a is 1 times negative 33, and then we have a positive 8, so we have a negative times a positive, and we need more positives. Well, I know 3 times 11 is 33, and if I have a positive 11 and a negative 3, that'll add to positive 8. So the first trinomial factors in, and I can split up the c squared into c times c. So then I have the minus 3 and I have the positive 11. And then see this divided by c minus 3? I can write it as a fraction, c minus 3, and then just divide it out. I don't know why exactly. I mean, you still see it sometimes even through pre-calc. I guess they're just kind of building flexibility to make sure you understand that the fraction bar is division. But we know that the final answer is c plus 11. Okay. I'm just looking to see if there's any others. Okay, so there will be some with the factor by grouping. So let's look at number 15. I'm just going to do kind of like the scratch work for this polynomial, 4 terms. So I'm going to do the factor by grouping, and remember, you got to pull in that negative if there's a negative in the second pair, which means that you have a negative 6 GCF in the second pair, okay? Because we want the signs to match the first pair. Now the first pair, the GCF is x squared, so the next step is x squared times x minus y minus 6 times x minus y, since a negative divided by negative is positive, and a positive divided by negative is negative. So then that first polynomial factors into x squared minus 6 times x minus y. Now you could keep it as just divided by the quantity x minus y, and just know that these two will divide out if you don't want to write it as a fraction. And then the final answer is just x squared minus 6, and you're done. Okay, so go ahead and finish these, pause the video, and then check the answer key, and ask any questions. Bring up any questions that you're stuck on.